Hello everybody, I'm Miss Heaton and I'm going to be teaching your lesson today. It's lesson 16 of addition and subtraction for Upper Key Stage 2. I hope you've got your practice activity from yesterday to hand and some pen and paper. So if you don't have all of those, just quickly pause me and gather them together and I'll see you in a moment. Before I share the solutions to these subtractions, I'd really like us to just quickly review the generalisation that you used in the last session. Let's say this together. If the minuend and subtrahend are changed by the same amount, the difference stays the same. Well done. And it's really important, isn't it? Looking at these mental calculations that you've been given, we can see that the minuend subtract the subtrahend gives us our difference. So you've been using your mental strategies to see what you notice about these numbers and see if you can transform the subtraction to make it easier. What did you get for the first one? Did you get 2,868? Well done if you did. How did you do it? What did you notice about this subtraction? That's right, did you notice that the subtrahend is close to a multiple of 1,000? Well done. And so what do we need to, how can we transform that to 1,000? We have to add on 4. Well done. And as we've said here, if the minuend and subtrahend are changed by the same amount, the difference stays the same. So if I add 4 to the subtrahend, I get 3,000. And if I add 4 to this, I get 5,868. And so it's really easy then, isn't it, to subtract a multiple of 1,000 from my minuend. And this gives us 2,868. Well done. Did you apply that to the rest of them? Let's have a see. Did you get 4,741 for this second one? What did you notice about the calculation? Excellent again. So we noticed, don't we, that the subtrahend is close to a multiple of 1,000. And it's really easy to subtract multiples of 1,000, isn't it? So if I subtract 5 from both the minuend and the subtrahend, then I can find my difference of 4,741 quite simply. What about the next one? Did you get 26,346? Well done. How did you do this one? What did you notice about the minuend and the subtrahend for this one? Yes, well done. So again, the subtrahend's close to a multiple of 10,000 this time, isn't it? What do I need to add on to that to make a multiple of 10,000? I need to add 15. Really well done. So if I add 15 to this, I get 30,000. And it's really easy to subtract 30,000, isn't it? Is that all I have to do though? No, well done. I nearly made a mistake there, didn't I? I nearly just transformed the subtrahend. And actually, I've got to transform the minuend as well, haven't I? So make sure that I add 15 to both of these. And then my difference will stay the same. Super. What about the next one? Did you get 45.85? Well done. What's different about this one? Yes, I've got a decimal fraction, haven't I? Does this make it any harder? Are the principles of subtraction the same? Yes, they are. So the minuend subtract the subtrahend is still the difference, but my place value reasoning is changing, isn't it? I've got to think about my strategies within a different part of place value. Let's have a see then. What do you notice about the minuend of the subtrahend? Yes. So again, the subtrahend's very close here. This time, it's very close to a power of 10, isn't it? A multiple of 10. How can I transform the subtrahend to a power of 10? I can subtract 3 100ths. Brilliant, 3 hundredths. So 0.03. And if I subtract 0.03 from both the subtrahend and the minuend, then my difference is 45.85. Because I can just then subtract 12 from the minuend. Excellent. And this last one of this group, did you get 7.78? Brilliant. I bet you're really pleased if you got all of those right. Now, how did you do this one? Did you transform the minuend and the subtrahend by the same amount? Fantastic. What was that amount? What did you notice? Oh, brilliant. See, I noticed that this was very close to 10. And actually subtracting 10 is really easy. So I also knew that I could use my number bonds to help me make round this up to 10. And so I added on 0.22. Because I added on 0.22 here, I had to add on 0.22 to my minuend, which again is quite easy to do, isn't it? So I got 17.78, and then I could just subtract 10. And subtracting 10 from 17 is really easy, isn't it? So I got 7.78. Brilliant. Hands up if you got all those right. Brilliant. Okay, so the challenge, again, really tricky for you to think about this one. We're thinking if the minuend and subtrahend are changed by the same amount, the difference stays the same. But perhaps this isn't quite as easy to transform as some of the mental calculations you've looked at there. So I'd like to look at this one in a little more detail. The challenge was to subtract 1,658 from 20,000. How did you get on with that? Did you find it easy? Did you transform the calculation to help you do it? I'm wondering actually, how many of you used a mental strategy and did anybody try and use a written method to help solve it? I'd like to explore some of those ideas. So if we think about solving this mentally first, perhaps you used a mental number line. And so we could perhaps start at 20,000, couldn't we, and subtract 1,000 and then 600 and then 50 and then 8 to find our difference. However, would that be particularly easy, do you think? There's quite a bit to it, isn't it? I've got to remember quite a lot of things going along there. So perhaps that's not particularly efficient. Did anyone use any other methods? It's interesting, isn't it, that not all subtractions lend themselves particularly well to a mental strategy, and in some cases a written method might be much more efficient. I'm wondering if a lot of you reverted to a written method for this one. So let's explore that in more detail, because I'd like us in this session to think about how we can transform calculations to make written methods easier still. Okay, did you write your written calculation like this if you were trying to find the difference using a written calculation instead of mentally? What do you notice about it? I notice that the minuend is a multiple of 10,000. Now, it's interesting, isn't it? In the mental calculations, when my subtrahend was a multiple of 1,000 or 10,000, it was really easy to subtract, wasn't it? Now that my minuend is a multiple of 10,000, does it make it easier or harder? I think it makes it harder, doesn't it? And why do we think it makes it harder? So in my minuend here, I've got an awful lot of zeros in the columns, haven't I? And so it's really difficult to subtract a unit from the column if the column's got a zero and if it's not got any units in it. What do I have to do then to solve that problem? We exchange, don't we? Fantastic. And exchanging is needed when there's an insufficient number of a unit to subtract from in a given column. So a unit is exchanged from the column to the left. Brilliant. Do you all remember that? Let's do that then. That sounds easy enough. So if I look at my ones column, I've not got a unit to subtract from, so I'll exchange from the column to the left. Oh, I've not got a unit to exchange there either, because I've got a zero in my tens column. Let's go to the next one on the left. It's zero again, isn't it? This is proving to be a little trickier, isn't it? And my next column, zero. Okay, so I'll have to start exchanging from here. Is that what you did as well? Let's give that a go then. So I have two 10,000s, excellent, and I'm going to give one 10,000 to my thousands column. Do you agree? Fantastic. Let's have a look at what that says. So two 10,000s, I'm going to exchange one 10,000, so I'm left with one 10,000 in my 10,000s column, and I have 10,000s now in my thousands column, because one 10,000 is the same as 10,000s. Super. Okay, what can I do now? So I have 10,000s in my thousands column, and I need to exchange from the column on the left so that I can get a unit in my hundreds column. Whew. So I have 10,000s. I'm going to exchange one of those thousands into my hundreds column. So how many hundreds do I have in my hundreds column now? 10 hundreds. So I am exchanging 1,000. So I've got 9,000s in my thousands column, and 1,000s is the same as 10 hundreds. Super. Let's do an awful lot of thinking here, haven't I? Okay, I still need to exchange from this column on the left now. So I have 10 hundreds. Let's do that one. So I'm going to exchange 100 to my tens column. So what have I got here now? So 10 hundreds, I exchanged one of those hundreds, which left me with 9 hundreds in that column. And 100 is the same as how many tens? 10 tens, fantastic. So I've got 10 tens now in my tens column. And I think have I got another exchange I need to do here? So I still can't subtract, can I, here, because I've got no units in this column. So I'm going to exchange from the left again. So I have 10 tens. I'm going to exchange one of those tens to my ones column. So 10 tens. If I exchange one, I have 9 tens in my tens column. And I now have, what do I have in my ones column? 10 ones. Fantastic. I've got 10 ones. Gosh, that was an awful lot of work, wasn't it? Did you all manage to do that? Fantastic. Can I complete my written subtraction now? Yes. Firstly though, I just want to check, has anything happened to my minuend? I've exchanged, haven't I, across each column through the zeros, but has the value of my minuend changed? No, it's not. Did some of you think that the value of my minuend might have changed? Shall we check? Let's see what we've got here. So we had one 10,000. Shall we count them up together? One 10,000 plus 9,000. So I've got 19,000 plus 900, 19,900 plus 90, because that's 9 tens. So 19,990. And I've got to add on 10 ones. 19,990 plus 10 is 20,000. Fantastic. So my minuend has stayed the same. I've just exchanged through the zeros to ensure that I have a unit in each column that I can subtract from. Okay, it's taken us quite a while, this, hasn't it? It's not as quick as a mental strategy, is it? Right, can I do the subtraction now? So I can say 10 ones subtract 8 ones is 2 ones. Fantastic. I've got 9 tens subtract 5 tens is 4 tens. Great. I've got 9 100s subtract 6 100s is 3 100s. You're a bit ahead of me there. And let's say this one together. 9 thousands subtract 1,000 is 8,000. Yes. And I've got 10,000 here, haven't I? 1 10,000, and I'm not subtracting anything from that. So I've got 1 10,000 there, and altogether my difference is 18,342. Oh, well done if you got that difference correct. However, it was really tricky, that, wasn't it, exchanging through all those zeros. And I'm wondering if we can use the same difference principle that you've been using to help us transform written calculations in the same way that we've been transforming mental calculations to make that process a lot easier. Shall we see if we can? Okay. I've written the calculation out again so that we can see our minuend, subtrahend and difference without all of the exchanges that we did. Do you think that we can transform this written calculation to make it easier to solve? We did that with the mental calculations, didn't we? So we rounded up and rounded down to the nearest thousand. That was a really good mental strategy that we used. Is that applicable here? So we need to, what was the biggest problem we had with the exchange? We need to be able to get a unit, don't we, into these columns that we can subtract from. So if we look at the ones column, what unit would need to be in the ones column, in the minuend, for us to subtract 8? We would need 9, wouldn't we? So perhaps I could add 9 on to the minuend and add 9 on to the subtrahend. Would that make it an easier written calculation? So 20,009 subtract 1,667. It's not particularly easier, is it? Because I've still got these zeros here. Perhaps I could add on 9,999. But then I'd have to add that to this as well, wouldn't I? And then I'm just making an awful lot of work for myself. I don't think that's going to work. Is there any other way I could transform 20,000? Perhaps I could subtract a small amount. I can hear you now. If I perhaps subtract, I could subtract 1, couldn't I? If I subtract 1 from 20,000 though, I've got to do the same to the subtrahend, because let's remember our generalisation. If the minuend and subtrahend are changed by the same amount, the difference stays the same. Well done. So I've subtracted 1 from my minuend, and I can see that I've got 90,999. So I have got units in each of the columns rather than zeros, so I won't need to do any exchanging, will I? And what do I need to do now? Subtract 1 from the subtrahend. Well done. And so I will get 1,657. Excellent. Do you think this is an easier calculation to solve? I'll tell you what I'd like you to do. Pause me now and write that calculation out and see if you can find the difference. See you in a moment. How did you get on? Did you write out 19,999 subtract 1,657? So 9 ones subtract 7 ones is 2 ones. 9 tens subtract 5 tens is 4 tens. 9 hundreds subtract 6 100s is 3 100s. 9 1,000 subtract 1,000 is 8 thousands. And 1 10,000, and we're not subtracting anything there. Brilliant. So what else do you notice? The difference is the same. Fantastic. And we can say, can't we, that 20,000 subtract 1,658 is equivalent to, it's the same calculation as 19,999 subtract 1,657, and that the difference will stay the same. So if the minuend and subtrahend are changed by the same amount, the difference stays the same. Really well done. I've quickly written it as a linear equation because I know you use this method using your mental strategies, and I wanted to make some connections to that. So I've got 20,000 subtract 1,658, and we just said, haven't we, if the minuend and subtrahend are changed by the same amount, the difference stays the same. So I'm subtracting 1 to get 19,999, subtracting 1 to get 1,657, and we found the difference was 18,342, which was the same. So written as a linear equation and doing the same jottings as you used for your mental strategies still gets us the same difference, because those two equations are equivalent. I know we represented some of our mental calculations on a number line as well, didn't we? I just wanted to put up those images there. So I've got my 2 written calculations and the number lines. I just want you to pause me and take a moment to have a think about what is the same and what is different. So pause me now and have a look at those and come back and tell me what you find. What did you notice? Okay, so firstly, what have you noticed on the number line? You've noticed that the difference has stayed the same. Fantastic. So we've got the same difference on the number line. However, we've just moved, haven't we, along the number line by 1. We've subtracted 1. And over here, we've subtracted 1 as well. But this difference has stayed the same. Brilliant. What did you notice in the written calculations? What was the same? The difference was the same. What's different? The minuend and the subtrahend are different. Brilliant. So the minuend here is a multiple of 1,000. The minuend here, we've subtracted 1 so that we can get the 9s. So we can have the unit of 9 in each of these columns to make our subtraction easier, and we've not had to do any exchange. Excellent. Did you find that much easier? Do you think we could apply that to some more examples? Let's have a go. Do you think we can use the same difference generalisation to solve this problem? Let's read it together. A famous pop star had 400,003 likes for an online performance. 24,438 of the same people also liked a video of a funny cat. How many people only liked the pop star? Okay, so we're finding the difference, aren't we? We're finding the difference between the number of people who liked the online performance and those who also liked the cat. Do you think you can help me write this in a linear equation? So our minuend will be 400,003. And I'm going to subtract the subtrahend, which is 24,438, and find the difference. Excellent. Now, if I want to put this in a written method, I'm going to write it out vertically. I'm going to ask you to do that shortly. But let's just very quickly think about how I could transform it to make my written method easier. Maybe we've got to change the minuend and the subtrahend by the same amount. We know that generalisation, don't we? What would happen if I subtracted 3? I'm looking at that and I'm thinking, oh, it's really easy to subtract 3 from 400,003. I'd get 400,000, and then I'd get 24,435 for my subtrahend. Would that be an easy written method? No, why not? I've got the zeros, haven't I? I've still got all those zeros in my minuend. What should I subtract it by then to get a number that doesn't have all those zeros in the minuend? If I subtract another 1, excellent. So if I subtract by 4 altogether, my minuend will be 399,999. And we know I don't need any exchanging then, do I? Have I finished now? No, I've got to subtract by the same amount on the subtrahend. So I need to remove one more there, don't I? 24,434. And for both those calculations, the difference will be the same. I think it's going to be an awful lot easier, isn't it, to write 399,999, subtract 24,434 in a vertical method. And that's what I'd like us to do now. I've written the original calculation out vertically, and we can see that's quite a tricky written method, isn't it? Because I'd have to exchange through all of those zeros. And you quite rightly told me, well, if I subtract 4 from both the minuend and subtrahend, I get this written calculation. 399,999 is much easier to subtract from because I won't have any exchanging. So I'd like you to have a go at that. So pause me now, write out that vertical calculation and find me the difference. How did you get on? Did you find it easy to find the difference subtracting from 399,999? Let's have a look at your difference. So 9 ones subtract 4 ones is 5 ones. 9 tens subtract 3 tens is 6 tens. 9 100s subtract 4 100s is 5 100s. 9 thousands subtract 4 1000s is 5 1000s. And 9 10,000s subtract 2 10,000s is 7 10,000s. And we have 300,000, don't we, which we're not subtracting from. Did you get the difference as 375,565? Super. So we know that that difference is the same for both of those calculations because we transform the minuend and the subtrahend by the same amount. So 375,565 people only liked the pop star, and they didn't like the cat as well. Fantastic, well done. Would you like to have a go at some on your own now? I've got a couple of examples here that I'd like you to transform and see if you can make them easier to solve using a written method. So pause me now and have a look at those. I'll see you in a moment. Let's have a look at the first one. I had 8,000 and I want to subtract 4,387. So that's how that would look vertically. I know that that would be really tricky to do because I'd have to exchange through the zeros. So I'm going to transform both the minuend and the subtrahend to make this written calculation easier. Now I know that if I subtract 1, I will get 7,999. That's really easy, isn't it? So I need to subtract 1 from the subtrahend as well. And I get 4,386. And so this is a much easier calculation now, isn't it? 9 ones subtract 6 ones is 3 ones. 9 tens subtract 8 tens is 1 10. 900 subtract 3 100s is 6 100s. And 7 1000s subtract 4 1000s is 3 1000s. Did you get 3,613 for your difference? Well done if you did. How did you get on with the second one? I'm going to write it vertically. So I've got 12,002 subtract 6,935. Now I know that that will be quite inefficient to do as it is because I've got these zeros to exchange through. So I'm going to transform my minuend and subtrahend by subtracting the same amount. If I subtract 2, it doesn't really help me, does it? So I'm going to subtract 3. And if I subtract 3, I will get 11,999. And so I need to subtract 3 from my subtrahend as well, which gets me 6,932. Now I can subtract the subtrahend from the minuend without any exchanging, can't I? So 9 ones subtract 2 ones is 7 ones. 9 tens subtract 3 tens is 6 tens. I've got the same unit in the hundreds column, haven't I? So 9 100s subtract 9 100s is 0 100s. Here, rather than exchanging, I can say, can't I, 11,000 subtract 6,000 is 5,000. And so my difference is 5,067. Well done if you got the same. You've worked really hard transforming written calculations using the same difference generalisation today. So we're going to stop there and it's time for your practice activity. You'll see there's a few calculations for you to transform there and also a written problem. See if you can apply the same principles. Put in a challenge for you as well. So we've got a two-step problem here. So I want you to think really carefully about estimating and your mental strategies and then transforming written calculations to make them easier. I hope you get on really well with those and I'll see you in the next lesson to have a look how you got on. Goodbye. Bye.